Hi everyone, welcome to GradeUp. My name is Hemant Parihar and today we are going to learn about the error control. In our previous lecture we learned about the flow control protocols and access control protocol. In flow control we learned about stop and wait, go back and selective repeat. In access control we learned about the time division multiplexing as well as CSMA CD. So now today we start error control. So let's start. So error can be of two types. One is that your packet get lost. So when your packet get lost, there are various ways we can detect it. For example, we are sending the acknowledgement, and there are other ways also. When you don't receive the acknowledgement, then after the timer you are sending the packets. So these are some of the ways by which we can detect whether a packet is lost or not. But the tough thing is when some bit of the some bit are changed and our data become corrupted. So that is very tough to detect whether some bits are changed or not. Packet lost is very easy, but bits gets changed, then it will be for us difficult to find it. So what solution you suggest to identify that whether some bits are changed or not? What kind of solution you can suggest it? So try to think it. The one simple solution is that sending 2 copy of a packet. When I send a 2 copy, so these are the 2 copy. So for every packet I am sending the 2 copy. So what is happening when receiver get these 2 copy, it's try to match these 2 copy. If they are the same, then it means that data does not corrupt. But if they are different, it means that somewhere something goes wrong. So and it can discard it and ask the packet again. But here is the one little problem is that we are transmitting we are sending lot of data. For single packet we have to send 2 packets. So actually, and our network becomes so much congested. So this is not flexible, this is not feasible because we are sending lot of data in that case. So what are other alternative we can suggest, and we will see those alternatives. So one of them is CRC, cyclic redundancy check. It is very popular at data link layer, we use it, cyclic redundancy check. So in cyclic redundancy check, what's happen, I tell you, we have a polynomial generator. So a polynomial is generated, we can generate it randomly, and both sender and receiver knows about this polynomial. So both sender and receiver know about this polynomial. When we actually implemented the CRC, this is actually 32 bit. This is x to the power 31. So and this is x to the power 0. So 32 digits can be there. But as we are taking the example, we are taking for only x power 3 so that it will be easy for us to understand. Because writing x 32's 1s and 0, it will be very tough to understand. So what we will do by this polynomial generator, we see what is the x power 3 is there, I write it 1. Then we will see x power 2 is there, I write it 1. Then I see x power 1, that is not there, so I write it 1, 0 for it. And x power 0 is there because here we have 1 into x power 0, we can think like that, and we have here 1. So this is what we got from this polynomial. See how I am getting, I am seeing the highest power first, then I am starting from here, and for those power which are not present I am writing 0, and those are present I am writing 1, starting from the highest power. Now suppose this is our data, now what we need to do, actually how much bits are there in CRC generator? 4 bits are there. So we need to add 3 zeros here, 3 zeros. So I am adding 3 zeros, and now I will tell you what procedure we are going to follow to do that. So I am writing the data here 1 1 0 1 1, and these 3 padded zeros I am adding here. And now what I am going to do, I am taking 1 1 0 1. This is our CRC and this is our data. Now it is look like that I am dividing it, some kind of division it is. So what I am going to do, see I am seeing that here it is 1. So I will write 1 1 0 1, and do the XOR operation. So what XOR says, 1 XOR, this is the symbol of XOR, 1 is equal to me 0, 0 XOR 0 is equal to me 0, and 1 XOR 0 is equal to me 1. So when bits are different, we are getting 1, but when bits are same, we are getting 0. So remember it and do it here. See, 1 1, it means we are going to get 0. Okay, I'm not writing that 0. What will I get here? It will be 0 and okay, write it 0, and this will we get 1 here, this here we get 1 here, and here we get 0 here, and I am taking this 0 and I will remove this because I will start from 1 and it is starting from 1. Now what I will do, I will take these all once again and do the same operation. So these are same 0, these are same 0, these are same 0, and these are different. So I will get here 1, and now I will take these two ones here and this 0 here. So it will be 1 1 0, and do the same thing again, 1 1 0 1, do the XOR operation again. What we will get? 0 0 1 1, and this is what we get, 0, and this is 0. So and we write it again, 1 1 0 1. We have to write till as we do in the division. Okay, it will 0 0 0, and this is 1. So take the last 3 bit. Why? Because we have added 3 zeros. So take the last 3 bit. This is our CRC. I have write it here also. This is our CRC. What CRC we got? So this is our CRC. Now what we are going to do, when we are going to send the data to the receiver, we are going to send this data as well as this CRC. So we will going to send 1 0 1 1 0 1 1 0 0 1. This is the CRC generated, and this is the data. We send it to the receiver. Now what will happen at the receiver side, I will tell you. First I will write what is the data we got, 1 0 1 1 0 1 1 1, okay, 0 0 1. So this is the data I have got from the sender. Let me verify it once, 1 0 1 1. Okay, that is same, and this is our CRC. This is our CRC, we are using it. Now I am going to do the same procedure again. If I get all the remainder as zeros, then there is no error in my data. If there is, I will not get all zeros, then means that something is wrong, data is corrupted or something has changed. So we'll do the same procedure again. I will write 1 1 0 1, and then you will see it become 1, this one become 1, and this is 0, and we will take it as 0. Now 1 1 0 1, all this becomes 0 and this is 1. Okay, now this and this, so it will become 1 1 and this 0. So it is 1 1 0 1, and I will get this as 0. Here we get 1, here we get 1, and these two will be from here, and 1 1 0 1, and I will get all zeros because this is same as this. So as I have got all 0, that means there is no error in the data. If I have got something different, then there will be an error in the data. Okay, you understand it? So understand the procedure, it is very easy. What we are doing, once you understand it, then it will be very easy for you, and try to solve 2-3 example, it will be very easy. Now suppose that some data has changed. Now suppose that some data has changed. So this was our actual data. Now think that it is changed like this. So I try to identify which bit is changed. So this bit is changed. So 1 become 0. Now let me try the same procedure that I am trying at receiver side and see what we are getting. So 1 0 1 0 1 1 0 0 0. This is what now the receiver has got because it is the changed one, and I am writing 1 0 1. This is my CRC. So doing the same procedure, 1 1 0 1. What I will get? Here 1, here 1, and here 1, and from here also 1. Now 1 1 0 1, here 1, now here 0, and this 1 comes here, and this 0 come here. Now 1 1 0 1, what we get? 1, this is 1, and this is 1, and then 0 1 0 come here. So this was the 0. Now 1 1 0 1, and what we are going to get? Here 1 and 1, and this 0. So we got 1 1 0 at the end, but we don't got all 0. So that means there is some error. But CRC does not tell where is the error, because CRC is a error detection method. It does not also correct the error. It just detect whether there is some error or not. So CRC has detected that there is some error and we have changed a bit also. So yes, there is an error. So this is, now you know that how CRC is working. Now we will see the checksum. So what's happened in checksum? We have a whole packet. What we do? We divide the whole packet into some bits. Here we divide it into 16 bit each. Suppose 16 bit each. Okay. Now when we take the 16 bit each and calculate their sum, decimal, what is their decimal sum, and then we add all of them. Whatever we got, there will be a field checksum. There is a field. It is 16-bit number checksum. So it will be in TCP header, and whatever we got by adding all those decimal values, we write the negative of it. For example, 248. Suppose we get 248 minus 248. I write it. Now what will receiver do? Receiver will take the packet and do the 16-bit again chunking, and then calculated their decimal value and then summing them up, and what should he will get? He should get 0. He should get 0, because when we have break it down our data in checksum field, we assume that it is all 0, and now when we calculate it as minus 240, right, we write it as minus 248 here, and when they sum it, it should be all 0. Okay, so it is very easy, and this is easy checksum. So try to understand it what it is. So it is just breaking the data and calculating their decimal value and putting the negative of it into the checksum field. So both of these methods, CRC and checksum, are not reliable, because sometime in CRC my bit get changed in such a way that I will get all zeros as remainder, but my data has changed. So both of these are not 100% reliable, but yes, the chance of it is very rare, because you will get your digit change in such a way that you will get 0 as a remainder, or in checksum also. Now this is a GATE 2017 question. Read the question properly and see what it is asking. So they are saying a computer network uses polynomial over GF2 for error checking with 8-bit as information bit. So 8-bit as information bit, and uses this polynomial. So it is different from our polynomial as the generator polynomial to generate the check bit. In this network, message is transferred. So this is the message. This is the message, and we have used this polynomial. Now we need to know what is we have sent to the receiver. What actual data we have sent to the receiver. So actually we are going to add the CRC to this and then send it. We are going to add the CRC and then we are going to send it. So let's see. So how to find the CRC? I have told you. So if you see that here it is 0. So okay, write it as 0. 0, 1, 0, 1, 1, 0, 1, 1. And we have to add how many 0? We will see. First convert it 1. Then x square is not there. It will be 0. X is there 1. Then x power 0 is there 1. Now this is our CRC generator, and what CRC we will get, we see. But you see here there is 4 digits, so we will add 3 zeros here and then do the processor. So you can remove this 0 because it is, we don't, as we do in division, it doesn't seems 0 to fit in the right position. So we start from the 1, 1, 0, 1, 1, and when you do it, it will become all 0. Now we will see all the 4 ones. It is actually this is 0, so ignore it, and 1, 1, 0 and 0. Now 1, 0, 1, 1, and if you do it, you will get here 0, 1, 1, 1, and this is 0. If you do one more time, 1, 0, 1, 1, you will get 0, 1, 0, 1. So we get CRC as 1, 0, 1, 1, 0, 1, and actual data is this. So if you write it, so it should be 1, 0, 0, 1, 1, 0, 1, 1. This should be sent to the this should be sent. So if you try to see which option matches, if you see last 3 digit, it should be 101 and C is the correct answer. So this is all about the CRC and the checksum. I hope you understand the CRC method. It is very easy. You just need to do a practice with 1-2 example, and once you understand the concept, then it will be fine. So try to do practice, try to do 2-3 example of CRC. That's all. Thank you.